Problem number 1800. Maximum ascending subarray sum. Okay, let's read the problem statement first. We have given an array of positive integers nums. Okay, we have to return the maximum possible sum of an ascending subarray in nums. Okay, a subarray is defined as a contiguous sequence of numbers in an array. A subarray is ascending if for all I where I is greater than equal to L and less than R, okay, in this range, my nums of I, okay, element at I index, it should be less than the element at I plus 1 index. Okay, note that a subarray of size 1 is also ascending. Okay, single element is also ascending, we can treat that as ascending. Okay, so now let's see this example number 1. So here 10 and 10, after 10 here it is 20. Okay, it is increasing order. After 20 it is 30, it is increasing order. After 30 it's 5. No, it is not increasing order. So this is one subarray, right? And what is the sum of this subarray? 30 plus 20, 50, 50 plus 10, 60. Okay, now you can start from here. Okay, so here 5 and after 5 there is 10. Okay, it is increasing order. 10, after 10 we have 50. Okay, so this element is greater than this element is greater than this. Okay, so this is one more subarray, right? And what is the sum of this subarray? 50 plus 10, 60, 60 plus 5, 65. Okay, so we have to return 65. Okay, we have to return the maximum possible sum of an ascending subarray. Okay, so 5, 10, 50 is the ascending subarray with the maximum sum of 65. That is my output is 65. Okay, now see this example number 2. 20 is greater than 10, 30 is greater than 20, 40 is greater than 30, 50 is greater than 40. So this complete subarray, okay, this complete array is in increasing order, right? And what is the sum of all elements? 50 plus 40, 90, 90 plus 30, 120, 120 plus 20, 40, and here 150. Okay, so 150, right? And see here 12 and here 17, then it's decreasing. So here 12 and 17, what is the sum here? It's going to be 29, right? 7, 9, right? Here 29. Okay, so 29 is the sum here. All right, then 15 is decreasing order. Okay, so 15. Okay, so this sum is just 15. Okay, and then it is decreasing order now. So from here we are going to start. So 13, it's 13 only. Okay, after 13 we have 10 now. And here see 10, 11, 12. Okay, this is for forming one complete subarray, okay, in which all the elements are in increasing order. So 12 plus 11 plus 10 is nothing but 33, right? So this is the ascending subarray with the maximum sum of 33. And see here constant size is very small. Okay, nums dot length is ranging from 1 to 100, right? So we can apply brute force here, right? So first I'm going to solve this problem using brute force, okay, in which my time complexity is going to be of n square. Okay, and then after that I'm going to modify my solution to just run in of n time complexity. Okay, so in this approach I'm just going to do the linear scan. Okay, and this is nothing but my brute force. Okay, so first how we are going to solve the problem using brute force. Okay, so what I'm going to do, I'm going to keep my I at this particular element. Okay, I, and then after that I'm going to start my j from here, let's say next element. Okay, and I'm going to check if this element is greater than this element. Okay, if yes, then I'm going to move my j further. Okay, then from here I will check if my this 30 is greater than 20. Okay, if it is true, then I'm going to move to my j. Okay, and same way I'm going to update my I to next position every time. Okay, I here, I here. Okay, now here I have to stop. Okay, so until here my sum is 60. Okay, max sum is 60, and now from the next time I have to start. So next time what I'm going to do, I'm going to update my I to j. Okay, and my I is going to start from here, and again my j is going to start from here. Okay, so this is the approach that we have to take in the brute force. Okay, it is very simple approach, right? So let me write the code, and with code you guys will get much better understanding. Okay, so here let's do one thing. Let's calculate the length of my nums array. Int n is equal to nums dot length. Okay, now after that what we need to do, we can simply run one loop. Okay, and we have to find out the maximum. So for that I'm just going to create one variable, int max sum is equal to 0, right? And then let's run one loop for int I is equal to 0, I is less than nums dot length, or you can say n. Okay, and here I plus plus, right? And now inside this we have to start the finding the sum, right, for a particular subarray. So a single element is also forming one ascending subarray, right? So here sum is equal to nums of I, right? And here I'm going to take j as the next element. Okay, I plus 1. Okay, and then after that inside this I'm going to run one while loop, right? And here I will just check one base condition. Okay, my j should be less than nums dot length or n. Okay, and here if my nums of I, okay, is less than nums of j, okay, so in that case only we have to update my sum, right? So that element is going to be part of that particular sub array. Okay, sum is equal to sum plus nums of j. Okay, and now every time, now next time my I is going to be updated to j and my j is going to become I plus 1. Okay, I plus 1, right? This is done. And here once this while loop ends, automatically my I automatically moving one step ahead, okay, because of this for loop, right? So now here I will just update the maximum as math dot max of maxsum, and here I will just write sum. Okay, and now you can just simply return this maximum and that's it. Okay, this is nothing but my brute force maxsum. All right, now let's run it and see if there's any code issue. We'll try to fix that. So all the test cases has been accepted. Now let's submit it. So see, our solution is accepted, right? So this is nothing but a brute force. Okay, now let's try to solve this problem using one linear scan. Okay, so in this case this one loop is running and this one loop is running, right? So of n square is going to be the time complexity. Okay, so now let's write the next approach. Okay, so here let me just reset. Okay, now in this approach what we have to do. Okay, so here see this, you can take this example only, uh 10 20 30. Okay, so here you can say that let's suppose this current element is 10. Okay, this current element is 10, then I am going to run one loop starting from the next element. Okay, from this element. Okay, 20 30. Okay, from here I am to start. Okay, so current sum is this. Okay, so I'm going to check if this 20 is greater than this 10. Okay, if 20 is greater than 10, then I have to add this here. Okay, if 30 is greater than 20, then I have to add it here. Okay, and next time when it is smaller, then I have to reset my current sum is to 0. Okay, so let me write the code first. Okay, then you guys will get much better understanding. Okay, so here initially let's take the maximum as int maxsum is equal to 0. All right, and now current sub array sum. Okay, so in the current sub uh, array sum. All right, so here just pick the first element. Okay, nums of 0. I'm going to start from here. All right, and then we have to loop through the array starting from the second element. Okay, so for int current index, or you can say I, int I is equal to 1 and I should be less than my nums dot length. So create one variable int n is equal to nums dot length. Okay, I is less than n and I plus plus. All right, now here see what I'm going to do inside this. So here if the next element, okay, if the next element is, let's suppose, not greater than the previous element, okay, but it is less than or equal to the previous element, okay, then we have to stop now. So if nums of my current index, okay, this I, okay, if it is less than previous element, okay, nums of I minus 1, okay, if this is the case, then in that case, if the current element is not greater than the previous one, then we have to update the maximum. Okay, then we have to stop, then we have to just update the maximum, whatever the maximum value that we have. Math dot max. Okay, and here simple maximum, and here what is my current subarray sum. Okay, that I have to update here. So copy this, paste it here. Okay, so this is going to be my maximum, and then we have to here we have to just reset the current subarray sum to 0. Okay, so this is clear, right? This case, right? So if the current element is not greater than the previous one, then we have to update the maximum, and then we have to reset the sum for the next ascending subarray, right? And if this condition is not satisfied, okay, if this condition is not satisfied, then we have to update the current subarray sum as nums of I. That's it. Okay, this is what we need to do, right? So single check. Okay, if a single check, right? So here in the end we have to do the final check after the loop ends to count for the last ascending subarray. Okay, so here I am just going to simply write return math dot max of maximum, okay, whatever the last maximum we have, okay, and current subarray sum, okay, for the last element. Final check after the loop ends to count for the last ascending subarray, right? So here let's run it and see if there any code issues. So this, see, how the test case has been accepted, right? Now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.